In Stat 136, we use the coefficient of determination, or R-square, to determine the goodness of fit for linear models with an intercept beta null. It is computed using SSR over SST. Another way we can compute this is 1 minus the ratio of SSE and SST. And if we recall, it may be interpreted as the proportion in the total variability of the response variable that can be accounted for by the set of predictors. In quantile regression, we have an analogous statistic that was developed to determine goodness of fit. This compares the sum of weighted distances for the model of interest with the sum in which only the intercept parameter appears. It is denoted by R of p and is also known as the pseudo R-square. In the next slide, we will see the formula to compute this. R of p can be computed by subtracting 1 and the ratio of the sum of weighted distances for the full pth quantile regression model and the sum of weighted distances for the model that only includes a constant term. Notice that this is similar to the structure of R-square, where we compute it using 1 minus SSE over SST. The equivalent of SSE in quantile regression is the residual absolute sum of weighted differences between the observed dependent variable y and the estimated quantile conditional distribution y hat, and this is denoted by v1 of p. Notice that this is the objective function we're trying to minimize in quantile regression. Meanwhile, the equivalent of SST in quantile regression is the total absolute sum of weighted differences between the observed dependent variable y and the estimated quantile q hat of p. Therefore, the pseudo R-squared is considered as an index comparing the residual absolute sum of weighted differences using the selected model with the residual absolute sum of weighted differences using only a model with the intercept. Now, why does R of p work similar to the coefficient of multiple determination? v1 of p and v null of p are both non-negative since they are sum of vertical distances with corresponding weights. Also, v1 of p is always less than or equal to v null of p. In practice, we can compute for the pseudo R-square for all values of the quantiles being considered to indicate whether the set of predictor variables influence the corresponding quantile. Therefore, the pseudo R-square is not a measure of goodness for the whole model because it is dependent on the quantile. If we evaluate it at a certain quantile p, we can assess whether the presence of predictor variables influence that considered quantile. We will see an example of this in our R demo later.